In this video, we will discuss about solid state. In the first in the first slide, I have written the contents which we have to study. The first one is basic concept of solid. The second is type of solid. Third is crystal lattice and unit cell. The fourth one is type of unit cell. In this The first one is basic concept of solid. As we know that solids have the definite shape, definite volume, and the particles of the solids are bounded with a strong intermolecular force, as we cannot compress them and we can't fill them in a container just like a gas. There are two types of solid, crystalline and amorphous. In crystalline, particles are regularly arranged, and in amorphous, particles are irregularly arranged. As we can understand this with within daily life example, as in a morning assembly, students were asked to stand in a row, which was an example of regularly arrangement, which is termed as crystalline solid. Whereas if the students were not standing in a row, which was an example of irregular arrangement, which are termed as amorphous solid. And in crystalline solid, there is a long order in the arrangement of particle, whereas in amorphous there will be a short order in the arrangement of particle. And the crystalline solids are termed as true solid, whereas amorphous solid are termed as pseudo solid, because they are representing the false properties of the solid, whereas crystalline solid are termed as true solid because they are representing the true properties of the solid. The true solid are also termed as perfect solid, whereas pseudo solid are termed as imperfect solid. The pseudo solids are also termed as supercooled liquid. And the crystalline solids have the sharp melting point, whereas amorphous solids have in the range in melting point. For example, glass has the melting point 1400 to 1600 degrees Celsius, whereas a uh, whereas a uh, whereas a NaCl has a melting point 801 degrees Celsius. The crystalline solids are in anisotropic in nature, whereas amorphous solid are isotropic in nature. As I have mentioned in bracket that different physical properties in different direction and same physical properties in different direction, which means they both reciprocate to each other. As the example of anisotropic in nature is, if we have taken a wooden table, then the speed of light will be different in different direction. If we take a glass, then the speed of light will be same in this different direction. So the examples of crystalline solids are salt, iron, gold, sugar, whereas the example of amorphous solids are glass, rubber, wax, etc. Okay. Now we can easily differentiate the crystalline and amorphous solid by their properties, by their arrangement, by their melting point, by their nature. We can easily differentiate them, uh, the solid. Okay. By their arrangement. Okay. Now the next slide will be, now we have to understand the crystal lattice and a unit cell. What is crystal lattice and what is unit cell? What is crystal lattice? As we know that all the solids are made up of constant particle, and the constant particle are made up of atoms, molecules, and ions. We all know that. In this, we have to discuss about lattice point, unit cell, and crystal lattice. We have to study these three: lattice point, unit cell, and crystal lattice. We can easily understand by the common example. Are um, many bricks are combined to form a room, whereas many rooms are combined to form a building. Similarly, many lattice points are combined to form a unit cell, and many unit cell are combined to form a crystal lattice. Uh, Bricks are correlate with lattice point, room is correlate with unit cell, and and the whole building is correlated with crystal lattice. We can easily understand by this example. Now we have to discuss the definitions. I have written the definition of three of them. First is lattice point. In crystal lattice, each atom, ion, and the molecule is represented by a single point, whereas unit cell, the smallest repeating part of a crystal lattice, whereas a crystal lattice is regular arrangement of the atom, ion, and molecule in 3D space. So we can say lattice points are combined to form a unit cell. Unit cell are combined to form a crystal lattice. This is the simplest example that you can correlate with to understand this, that all bricks subsist. Now we have to discuss the type of unit cell. There are two types of unit cell: primitive and non-primitive. Primitive is those unit cell in which particles are only present at the corners, whereas this is example of simple cubic unit cell. And you can see the diagram first in a cube in which the corner atoms are represented by a dot. As we know that in a cube there are 8 corners, 6 faces, and 12 edges. Sorry, 8 corners, 6 faces, and 12 edges, as we all know that. So if the particle are only present at the corner, then it is termed as primitive unit cell. Primitive unit cell, if the particle is present at the corner and also some other points, like at the center of the cube, at the face of the cube, at the edges of the cube, each edge of the cube. Like now you can see the diagram 2, which is written as BCC, body center cubic unit cell, in which particles are present at the corners and also at the center of the cube, whereas in FCC, face center cubic unit cell, in which particles are present at the corner and also at the faces, each face of the cube, whereas in ECC, which is termed as edge